All right, in this video, I just want to go through some, give you some notes on when you're doing graphs of quadratic functions. All right, these are really a special case of a polynomial, and you really already know a lot about graphing these, like you've already graphed y equals x squared. And, you know, we already know negative x squared would go this way. We've talked about that a couple of times. So you've already done some graphing of quadratics. And this just is looking at two forms and what you get out of those when you have them in these forms, what you can find quickly and easily. Okay, so with both forms, you see the A, that's the same A on both of these. It's like I could take the first form and turn it into the second form by doing something called completing the square. But really, I just expect you to know what you get out of the form as it is without having to convert it to a different form. So on both of them, the A is the direction of opening, okay? So if the A is bigger than 0, that means the A is positive. Then your parabola is going to open up. And that if A is less than 0, that means A is negative. Then that means it's going to open down. So you know that at a glance, just based on the sign of what's in front of the squared term. And if it were equal to 0, you didn't have a parabola, you'd have a linear function. All right, now the vertex is one of the main points of this whole thing. So make sure you pay attention to the vertex. With the vertex, when it's in the ax squared plus bx plus c form, there's a formula that you use to get the x coordinate of the vertex, okay? It's negative b over 2a, okay? And that also is a portion of the quadratic formula, so that's the way I remember it. And that's the only thing I remember. I don't memorize the y coordinate. The y coordinate is just what you get when you plug in negative b over 2a. A good way to think about it is if I had used function notation on this, okay, then the y-coordinate would be f of that number, just plugging in negative b over 2a for x and working it out, okay? All right, now what the vertex is, the vertex on a parabola is that spot where it makes the turn, right? The high or the low point. Right? So when you're thinking about this, you don't know whether it opens up or down, but the vertex is going to be that spot right there. All right? When they talk about the axis of symmetry, they sometimes talk about the line of symmetry. It's not going to it doesn't like me to write inside those boxes. I'm just going to erase that. All right, so it might say axis, it might say line. Either one's fine. What it is this line that you could fold the parabola up around and have the two sides match up. So symmetry is when if you fold along that line, the two sides would match up, okay? And so it's related to the vertex. Do you see how it passes through the vertex? So it's going to be x equals, so if this is negative b over 2a something, then it's going to be x equals negative b over 2a. The vertical line, so x equals that number that's the x coordinate of your vertex, okay? All right, so what I'm doing on this video is just filling in the basic notes page, talking through that with you. All right, now the x-intercepts for any function, you find those by letting y, by letting y equal 0, okay? Let me just get rid of that. So I'm just going to put it here. So you let y equal 0. Well, what that means is you're really trying to solve then ax squared plus bx plus c equals 0, which you would do by factoring maybe, or by using the quadratic formula. So that's what the quadratic formula is really doing. If you thought of it in terms of the graph, it's helping you find the x-intercepts. Okay, and so that the x-intercepts, that's what you are doing when you're solving something like ax squared plus bx plus c equal to 0. You're letting the y be 0, and you're finding what are the x's that make that equal to 0. And in terms of like function language, you're finding the zeros of the function, okay? And notice right here is the negative b over 2a. Okay. So like this expression contains the formula for the vertex, contains that halfway point, and I can explain during class how to think about that or why that's the case. I don't think I'll do it right now. All right, then for the y-intercept, for any function, the y-intercepts are found by letting x equal 0. Okay, so you can see if you plugged in a 0 everywhere, there was an x, then that's gone, and you get a c for the y-intercept. So the y-intercept is c. So c, or you can think of it as the ordered pair 0, c, is the y-intercept. And back to the x-intercepts. So negative b over 2a, negative b plus square root of b squared minus 4ac over 2a, and negative b minus square root of b squared minus 4ac over 2a. Those are your two x-intercepts, and if you had to write them as an ordered pair, you could put a 0 at the end, okay? You just normally don't have to. Okay. All right, so so that's that form. And then in the next video, I'm going to go through all of those features and kind of talk you through doing a sketch of the graph when it's in that form, kind of talking you through all of those. And then I do the same thing with y equals negative 2 times this. So I'll do this in the next video. Okay, I'll do the examples. All right, let me go ahead and fill in the notes page for the other form. Okay, now this one right here, I call this the vertex form. I don't think that's the official word for it, but that's what I get out of that one at a glance. That's so nice. With this form, I can see the y-intercept easily, okay, but the rest of it's not so easy, okay. So over here, the vertex, you have to make sure you're comparing it to this form. Then the vertex turns out to be HK. So it'll be the opposite of whatever you see in there. Okay. And then it'll be whatever the K is. So let me just do a couple little quick examples. So like if you had y equals negative 2x minus 3 squared plus 4, the vertex would be 3, 4. Okay. If you had y equals 3 times x plus 1 squared plus 4, the vertex would be negative 1. See that minus h? It would be negative 1, 4. Okay. If you had y equals, 5x plus 1 squared minus 2, the vertex would be negative 1, negative 2. So the k part, you just take whatever you see there. Okay. And then there's one more possibility. What if you had x, maybe it was x minus 2 squared, and then maybe it was, let's see, I need it to be negative, negative. Maybe they're both negative like this. Then it would be 2, the opposite of that, which would be 2, and then whatever you have there, negative 4. All right, but I can get it without any work or any effort. And then just like before, the axis of symmetry is the vertical line x equals to whatever the x coordinate of your vertex was. Okay. And then for x-intercepts, I still let the y equal 0. And so I'd have to solve this equation. And I could do it in general. I could move the k out of the way. Okay. I could divide by a. I could square root both sides. You're not going to memorize this, though. You're just going to do that process. Make sure you get both oops, I haven't, yeah, I have square rooted. Okay, then you're going to add the h. And that's how you would do it. And using the square root method is normally what you would wind up doing on that. But I'm not going to write that for you. You could do it in general, but there's no formula to memorize. You just do the process. And I'm going to say, usually using the square root method. Okay, but you could multiply all that out, add the k, and then convert it, or you can convert it to this form over here and use the quadratic formula. Okay, and then on the left side, finding the x-intercepts, usually try factoring or use the quadratic formula. Okay. All right, and then one last thing I need to tell you about is the y-intercept on that one. So the y-intercept, you're letting x be 0. So I really could just plug in the 0 and get a formula. Okay, so I could, y would wind up being what I would get if I plugged in 0. And so there is a formula. This would be negative h squared, which would be h squared plus k. But again, you're not going to memorize that. You're just going to plug in 0 for x and see what happens, okay? You're not going to memorize it. So don't memorize. Just do it. Okay? And so I'll go through the sketch and the rest of it on the next video.